6, 9, 2, 4, 4.5. Okay, so this is our what? XY plane or XY plane. Come on. And this happened to be our in plane, right? And then there are the two circles.
Is that given in the question, Eugene, or how would we know what's in plane and out plane?
It's in the question because the biggest area is the in plane.
Right.
Right?
Okay.
Textbook don't tell you this, okay? I was trying to find it when I was teaching this course. Can't find it at all. Then later I look at different question, oh, bloody hell. To them it's obvious, to me it's not. That's why I want to make it obvious to all of you. So this is. So can someone make a comment on this condition? Can someone make a comment? Anyone? So the comment that I was looking for is this.
Can I say something?
Yeah, you can say something. Obviously, it's a free country.
I guess the area, I mean, the radius of the two outplanes combined equals the radius of the in plane.
Yep, you can say that. But what is that is absolutely true. I'm not saying wrong. But what you can see from here? Anyone? Come on, where I'm drawing you, what can you observe from this condition? Okay, for this condition. Anyone?
Max shears in plane.
Has a...
The max shears in plane.
Yes. So if the max shear is in plane, so what? The thing is so what, right? Can you use 2D Mohr circle to solve this?
Yes.
There you go. So there you go. So this is a situation that you can use 2D Mohr circle. Right? But you have to be you have to check. Like what I always quiz you guys, right? Check. How do you know that this is a maximum? You have to check. As engineers, we always have to what? Check and be sure and you don't lose life. Check and you don't check, you might lose life, okay? The difference with us is this. When you design a plane, the number of people will die if there's an accident, okay, is usually less than 300. Am I right? Okay. As structural engineers, this is how serious your work is. That's why I'm not mocking around when I teach this course. When some of you in manufacturing, you see me teaching in manufacturing courses, I'm Mr. Fun. I'm the angel. Down here, I'm like the bloody devil. For this reason, because any analysis that fail, it's not 1% that die, it's not 2% that die, it's not 5% that die. It can be 1,000 people, it can be 2,000, it can be 3. Okay, so that's why it's so difficult for me to relax in this course. Okay, that is the critical part. I was very relaxed years ago, long time ago. But when I was an expert witness, it woke me up. Okay, what you guys are calculating, are analyzing is important. Don't take this lightly. Okay, don't take it lightly. And some of you are taking this so very seriously, and I like it. Okay, that reflect in your term test too. Right, so for this case, you will realize is this. Okay, what you see from here is this, that the tau max. Right, that the tau max is equal to tau max in the xy and is also equal to tau max in a yx. Okay, so this one will be equal to stress y minus by stress x divided by 2. Okay, and this is what we call our in plane. Okay, so if stress max is equal to stress X or stress, did I got this wrong? Yeah, stress X. All right, and then stress Y or stress mean is equal to stress Y, right? So you can have this as stress max or the maximum shear is equal to stress max minus by stress mean by 2. And I make a mistake down here. Okay, so this should be stress X. Okay, so I'm going to write this, but be careful. You have to check. Okay, please check. Okay, if you don't check, I'll be able to use 2D Mohr circle analysis, but please check to confirm. Okay, you can, but I want you to have a habit of checking. Okay, the case I did was engineer. In fact, the principal engineer thought it was 2D Mohr circle is sufficient. Okay, that's where everything did not work out. Right, and the final one. Okay, and the final one is condition number 3. Okay, I'll write down condition number 3. You guys finish copying. I think there's no one telling me to go back. And then this is condition number 3. Is where stress X is smaller than stress Y is smaller than stress Z. Okay, and all are positive. Okay, this is the final case. I cannot wait to show you guys the example that I'm going to show you. I know you guys will have fun. Okay. So the same circle or the same element. Okay. So now, come on. So this is our stress Y, and this is our stress Z. Okay, you can see that now, right? You can see. So all of them are positive. That's why all of them are pushing upwards. Okay, all of them are positive, but stress Z is the biggest. Smallest is stress X. Okay. So from here, I'm just going to focus on the positive side, which I'm trying to most of the time in my life. Okay, it's trying to focus on the positive part of life, clockwise, anti-clockwise. Okay, so I'm going to draw 3 lines. So 1, 2, and 3. And this is our stress Y. No, stress Z. Sorry. Okay, so this is our point X, point Y, point Z. Right. So our first circle in plane. Okay, so this is our XY plane. This is our in plane. And then we have YZ. And this is out of plane. And finally, This is our XZ plane, which is again out of plane. And then we realize, right, tau max is the out of plane. Okay, so tau max is equal to the shear max on our XZ. Okay, so this is our maximum. Okay, so this is our out of plane. So for this case, you have to use 3D Mohr circle. You have to. If not, you are in a big doodah. Okay, imagine if you only use 2D Mohr circle. Imagine you only use 2D Mohr circle, right? And then you call on the principal stress. In fact, Z is your much higher one, and you are done. Okay, the material will fail in tension, in shear, in any way you can. It's going to be a catastrophic failure. Okay, so from here we know that tau max is equal to tau max xz and is equal to tau max zx. Okay, and to calculate the value is not difficult at all, right? So this we know, as I mentioned before, is out of plane, right? And then to calculate this tau max in the xz is equal to stress z minus by stress x divided by 2. Okay, so if we let stress max is equal to stress z and stress mean is equal to stress x, okay, so tau max, okay, is also equal to stress max minus by stress mean divided by 2. Okay, so this is 3D Mohr circle. Okay, now we're going to go for an example. Okay, we look at example. And this example, I have uploaded this. Okay, I've uploaded this on Avenue to Learn. Okay, I've uploaded this, so I'm going to bring this here. Okay, I have. Okay, so this is. Okay.
Sorry, Eugene, could you go back for a second?
Yep, I can.
Thank you.
Okay.
Thank you.
Okay. Okay, so this is the example I'm going to do. Okay. Look at the math. Whoa. Can you all see the math? Right? Might as well we pack up, we go home, right? This is the solution manual, by the way. You know what? I have not a clue what they are doing. I will tell you that. Okay. I have not a clue what they are doing and why. Okay. So forget it. Okay. Put this right. So the only thing that when a solution manual is posted, I think you guys know by now. Why is this rejected? I don't know. Okay. Why is this why is that rejected? I don't know. And then what else? 1A, 1B. Why is this? Wait, there's a value. Why this? What are they calculating down here? I have not a clue, right? And then case number 2, what are they doing down here? I don't know what they're doing down here. Okay, seriously. Okay, what are they doing down here? And then all of a sudden they have this as okay. Okay, right. This is a problem where they combine U strength, okay, and Mohr circle together. Did they tell you anywhere at this stage? No, nothing. They just say, boom, go for it, have fun. Okay, that's why solution